Hello everyone, I welcome you all in this session of geometrical optics. So recently we have done with this particular chapter, alternating current, and now this is the new chapter that we are going to trace is geometrical optics. Good afternoon, Sneha. Good afternoon, everyone. So make sure the screen is visible to you and I'm audible to you. If it is so, please make yes in the chat box. Okay, Nagashri. Good afternoon, everyone. Good afternoon. Okay, so I hope कि screen सबको visible है and audible भी है. Then we will start the session. Here we are going to learn ray optics today. ठीक है? Ray optics में भी what is the learning objective of today's class? First of all, we will understand the propagation of light, then reflection of light, and laws of reflection from plane mirror. Now, this chapter is specifically related to the light, how light behaves in different condition, different circumstances. This chapter propagate around light only. Okay. So, in the very first introduction of this chapter, if you will see here, light is nothing but the tool which enables us to see the world. Okay. You are seeing me, you are seeing the screen of the PC, and you are seeing everyone around you, including some objects, including the objects also. This happens because of the light. What is that tool? That tool is light that enables us to see the world around us. Got it? And the study that we made to learn more about the light is nothing but optics. So the branch of physics that deals with the behavior of light and other electromagnetic waves, because light is also electromagnetic wave. So I'm saying it here that branch of physics that deal with the behavior of light and other electromagnetic waves is called optics. Got it? What it is called? It's called optics. This one. Got it? But what is ray optics then specifically? ray optics signify करता है. So light beam can then be treated as a ray. ठीक है? So whichever the optics we are studying, either it is ray optics or wave optics, we have the different situation for these two optics. If we are talking about ray optics, we assume the light is made up of ray. Light is nothing but a ray, okay, that propagate in the vacuum and in other mediums. Got it? And if it is a ray, that it follow the rules of geometry, because in mathematics ray follow the rules of geometry. Okay. Then this light also behaves as ray in ray optics and follow the rules of geometry. That is why we will say it as geometrical optics also. Got it? Or light beam then can be treated as a ray whose propagation is governed by simple geometrical rules. Okay. Now, the part of the optics that deal with such phenomena is known as geometrical optics, which means in geometrical optics you have to consider light as a ray, and all the geometrical laws is applicable to this particular ray. Okay? That part of optics is geometrical optics. When we assume the light as a wave, then that particular part of optics is wave optics. That is the next chapter. Now, if you see here the propagation of light, so light always travels in a straight line path. Okay? Whether it is in a medium or it is in vacuum. Okay? So the path of the light or traced by light ray is a straight line. Okay? This path can change based on the object that we put in front of the light. Okay? So the path of the light changes when there is an object in its path or where the medium changes. Okay? Like initially the light is traveling in vacuum and suddenly the light enters from vacuum to water. So in that case, medium is changing, the propagation of light also changes. Got it? Now, light that starts from a point A and passes through another point B in the same medium actually passes through all the points on the straight line AB. तो अगर लाइट ने ऐसे स्टार्ट किया, ये पॉइंट ए है और ये पॉइंट बी है, and these two points lies in the same medium, so light ray will follow all the particles, or sorry, all the points present in between this ray. Okay? Because light ray is traveled in a straight line, so whether the straight line connecting to A and B, light will passes through all the points in that line. Okay? And such a straight line path of the light is called a ray of light. Got it? Now light rays start from each point of a source and travel along straight line till they fall on the object or a surface separating two mediums. A bundle of light rays is called a beam of light. तो इसका मतलब क्या हुआ यहाँ पे? What does it mean? ये मेरा कोई सोर्स पॉइंट है जहां से मेरी लाइट रेज इज कमिंग आउट इन द फॉर्म ऑफ अ स्ट्रेट लाइन. ठीक है? ये कब तक एक स्ट्रेट लाइन में मूव करेंगी, तब तक इनके रास्ते में कोई ऑब्जेक्ट नहीं आ जाए. जैसे ही कोई ऑब्जेक्ट आएगा, देन दे विल डिफ्लेक्ट फ्रॉम देयर पैथ्स according to the properties of the surface of that particular medium. Got it? Now, if I combine these rays, let's say these are the number of rays, then this combined known as beam of light. Beam of light. Got it? Till now, if anyone had any kind of doubt, you can ask. Now, we are going to discuss about the reflection of light. Till now, we have discussed what is light. सॉरी, व्हाट इज लाइट पे तो पूरी जीवन आप बिता दोगे तब भी नहीं जान पाओगे. ठीक है? बिकॉज लाइट इज वेरी कॉम्प्लेक्स फिनोमिना ऑफ द यूनिवर्स. ठीक है? बट वी नो by the experiments or by the theoretical aspect that light is an electromagnetic wave that travels through one medium to another medium, It travels in a straight line path and behave as ray. Got it? अब ये रे की तरह बिहेव कब करेगी? When the object from which it is getting deflected are much more in dimension if you compare with the wavelength of the ray. ठीक है? Wavelength of the light. So generally the mirrors, the spherical mirrors or the surfaces that is exposed to light are very large compared to the wavelength of light. Their dimension is very large compared to the wavelength of light. So in that case, that particular light behaves as a ray, and that ray is a straight line path that is followed by light itself. Got it? It depends on medium also. If you are throwing the light into a vacuum and suddenly you changes the medium of light, the path of the light will change. Got it? Now reflection of light. Now what is reflection? So whenever the light ray fall on a polished surface or a surface specifically, then it bounce back in the same medium. This phenomena of light is termed as reflection of light. Okay? We are able to see the objects because of the reflection of light. Okay? This enables us to see the world around us. Although reflection also plays a role, but vital role or the main role is played by this reflection. Okay? So when light rays strike the boundary of two media, यहाँ media is the plural for medium. We have a medium. Medium का plural जो होगा वो होता है media, which means more than one medium. Got it? So when light rays strike the boundary of two media, such as air and glass, a part of light is bounced back into the same medium. This is called the reflection of light. As you can see here, suppose this medium is air. The light is coming from air. After striking this surface at these 3 points, it travels back or it bounces back in the same medium. That phenomena of light ray is termed as the reflection of light. Okay. Now there are two types of reflection. First is regular or specular reflection, and second is diffused reflection. Now, what is regular reflection? So when the reflection takes place from a perfect plane surface, got it? Perfect plane surface, and after reflection rays remain parallel, it is called regular reflection, which means light ray comes from one medium, it strikes the plane surface and travels back to that medium. Got it? But it remains parallel. पैरेलल का मतलब क्या हुआ? देखो यहाँ पे 3 रेज हैं. जब ये इंसिडेंट हो रही हैं तो तीनों की तीनों एक साथ पैरेलल है. रिफ्लेक्शन हुआ उसके बाद जो रे बनी रिफ्लेक्टेड रेज, these are also parallel. So these types of reflection, this type of reflection is termed as regular reflection. Regular reflection. Clear? Now, what is diffused reflection? Diffused reflection. So when the surface is rough, most probably and most general, all the surfaces are rough. No surface is perfectly smooth. So there is kind of roughness in all the surfaces, which means all the reflection are lies in the category of diffused reflection. So when the surface is rough, light is reflected from the surface in the form of bits of its plane surface in irregular directions. This is called diffused reflection, and this process enables us to see the object from any position. ठीक है? देखो कैसा होता है. This is the specular reflection or regular reflection. And this is what? This is the, just a second. This is the diffused reflection. So here you can see the surface is not smooth. Surface is kind of rough. So that is why, although the rule of reflection or the laws of reflection is also valid in this case, but you can see the directions. If you compare these two rays, they are no parallel to each other. These two rays are not parallel to each other, which means the parallel phenomena is only happened in the smooth surfaces. Got it? But all the surfaces are what? All the surfaces are rough. And that is why we are able to see the object from any direction because of this diffused reflection. Because अगर कोई ऑब्जेक्ट इस तरह से प्लेस्ड है तो जहां पे भी रे पड़ी होगी वहां से रिफ्लेक्ट होकर के ये हमारी आईज तक आती है, तभी it enable us to see that object from any direction. Got it? Now, laws of reflection. Laws of reflection में there is simple terms that we have to use. Firstly, you need to understand the terminology that which represents what. So here it is a mirror which is laid on the surface like this. This is a kind of mirror. ये mirror है, ठीक है? ऐसे मैंने ये mirror रखा हुआ है. Now a ray is falling onto this like this. ऐसे ये मिरर है, ये रे ऐसे आ रही एंड रिफ्लेक्ट बैक होकर के ऐसे जा रही, ठीक है? नाउ व्हाट इज दिस रे कॉल्ड? व्हेन इट इज स्ट्राइकिंग द मिरर, then this ray is called incident ray. After reflection, this ray will become reflected ray, ठीक है? And a normal drawn to the surface of mirror is called normal to the mirror. Plane normal to the mirror. Got it? The incident ray made an angle with the normal is called angle of incidence, which is I. And the reflected ray made the angle with the normal is termed as angle of reflection. Okay? Or reflected angle. This I is nothing but angle of incidence, and this R is nothing but angle of reflection. Clear? So here these are the two rules for reflection. Firstly, this incident ray, this reflected ray, and this normal to the plane of mirror lies in the same plane. So if you will see, this is the plane in which this plane include the incident ray also, normal to the plane also, and reflected ray. So this law satisfies here. First condition is satisfied. Second condition here is the angle of incident must be equals to the angle of reflectance. Okay. So here this angle I should be clear. केसेस हमने डिस्कस किए. एंगल ऑफ रिफ्लेक्शन सभी को क्लियर है? Laws of reflection. First law is that incident ray okay, incident ray, reflected ray और normal ray, normal to the plane of mirror lies in the same plane. ठीक है? Second is angle of reflection is equals to angle of incident. ठीक है? Now, in the first case, if you will see, this is a plane mirror. Incident ray falling on this mirror and going back. If you're able to see here, we have represents this incident ray as E cap, vector addition में, vector notation में. So this E cap is denoting the unit vector in the direction of incident ray. This R cap denoting the unit vector in the direction of reflected ray. And this N cap is denoting the unit vector in the direction of normal. So these three are nothing but the what? Direction vector. got it? This is a curved surface, so for that also you need to draw a plane. यहाँ पे incident ray आई, at that point you need to draw a plane like this, horizontal plane or the tangent to that plane, and then it reflect back. Similarly it happens to this. Clear? Now there is also one term which is the vector form of vector form of laws of reflection. ठीक है, तो ये वेक्टर फॉर्म आजकल थोड़ा ज्यादा पूछी जा रही है, दैट्स व्हाई यू हैव टू लर्न इट, which is nothing but r cap is equals to e cap minus 2 times e cap dot n cap into n cap. Clear? So r cap is the unit vector in the direction of reflected ray. I'll write it here. R cap is nothing but the unit vector in the direction of reflected ray. Clear? E cap is the unit vector in the direction of incident ray. And n cap is nothing but unit vector in the direction of normal to the mirror. Clear? So r cap is equals to e cap minus 2 times of e dot n into n cap. So I hope you understand that. You must remember this expression because nowadays uh, the probability of asking this in direct MCQ has been increased. Okay, for last 2 years. Now there are some key points here. First of all, जो point है, that is rectilinear propagation of light. Rectilinear means in a straight line, in the same way. So in a homogeneous transparent medium, light travels in a straight line. We know that. ठीक है? When a ray of incident normally on a boundary after reflection, it retraces path. तो जैसे ये प्लेन मिरर है, यहाँ पे ये जो रे आई वो 90 डिग्री पे आई. ठीक है, इंसिडेंट नॉर्मली. सो व्हाट इट विल डू, इट विल रीट्रेस इस पोजीशन. क्लियर है? तो यहाँ पे एंगल ऑफ इंसिडेंस एंड एंगल ऑफ रिफ्लेक्टेंस विल बिकम जीरो. सो whenever a normal incident is happening, then you can say the path of the path of the ray is repeating itself. ठीक है, or retraces itself. In the same way, here you can also see this ray, this particular ray, this one, it is falling normally to this plane, then it retraces its position. This ray is also falling normally to the plane of the mirror, then it's also retracing its path, and this ray is also falling normally, so it's retrace its path. Here also it's retrace its path, यहाँ पे भी retrace किया. What we can do, if we just extend this ray at this point, it seems that light is coming from this point. Okay? Although there is no light in that place, but it seems that light is coming, retraces its path from that point. And that is why this particular image is virtual image. We will see a detailed view on that what is image and what is object actually. Okay? And these mirror also, concave mirror and convex mirror. Now, ये कुछ इंपॉर्टेंट पॉइंट है डाउन साइड में, यू हैव टू नोट दैट frequency, wavelength and speed does not change on reflection, which means जितनी एनर्जी कंटेन करके this ray is falling on this particular surface, it retraces with the same energy. Okay, there is no loss of the energy because energy is somehow related to frequency. Wavelength and speed also does not change on reflection. ठीक है. And our eyes is mostly sensitive to yellow color and least sensitive to violet and red color. ठीक है. तो इसी कारण की वजह से जो मोस्ट ऑफ द कमर्शियल व्हीकल आर पेंटेड एज येलो and sodium lamp on the street road we use at road lights. ठीक. Because our eyes is more sensible to this yellow light. Now try to solve this one. JEE Main 2023 previous year question है. An object is placed at a distance of 12 centimeter in front of a plane mirror. The virtual image by the mirror. Now the mirror is moved by 4 centimeter towards the stationary object. The distance by which the position of image would be shifted will be. तो देखो ये हमारे पास एक प्लेन मिरर है. क्लियर है. अब प्लेन मिरर के पीछे तो कुछ नहीं होता. So whatever the image we see in a plane mirror is a virtual image because there is nothing exists on the back side of the mirror. So that image is the virtual image. So let's say object is placed here at this point O and this distance is 12 centimeters. So always remember for a case of plane mirror and for a case of normal incidence also, the image will also form at the exact same distance away, which means object की जो image बनेगी that is also 12 centimeter away from the object. Now what we have done, the mirror is moved by 4 centimeter towards stationary object, यानी इस तरफ ये shift हो. अब यहाँ ये shift हुआ तो this distance has also been shift. कितना shift हुआ? 4 सेंटीमीटर. 4 सेंटीमीटर शिफ्ट हुआ मिरर, विच मीन्स अब जो डिस्टेंस आएगी नई इमेज की, इट डिपेंड्स ऑन द डिस्टेंस ऑफ ऑब्जेक्ट फ्रॉम द मिरर. नाउ द न्यू पोजीशन इज दिस एंड दिस डिस्टेंस इज 8 सेंटीमीटर. ठीक है. बिकॉज 4 सेंटीमीटर द इमेज हैड शिफ्ट towards the stationary object, so the actual distance now is 8 centimeter. So image will also form 8 centimeter away. Here image will also shift at this point by 4 centimeter, but the distance of image from the mirror is 8 centimeter on this. 8 centimeter. ठीक है. So what is been asking, the distance by which the position of image would be shifted. So that position is nothing but 4 centimeters towards mirror. Clear? किसी को कोई डाउट है इसमें? Any kind of doubt in this question? Say yes and no in the chat box if you are having any doubt. Okay, Madhukar. Let me solve this question again for you. I don't think that you have got it. Acer is asking, sir, how it is 8 centimeter. I know that I am solving it again. I know that you haven't got it. So let's say this is a plane mirror. So concept of image formation is same. Okay. If the object is x distance away, for a plane mirror, the image will also form at x distance away on the opposite side of the mirror. This is image, this is object, and this is the plane mirror. Now here, in this case, this object is 12 centimeter away. This distance is 12 centimeter. So image will also form at 12 centimeter away. This is image. And this distance is also 12 centimeter. Got it? Now, we have shift this particular mirror 4 सेंटीमीटर टुवर्ड्स द स्टेशनरी ऑब्जेक्ट, ऑब्जेक्ट तो यहीं पे ही है, तो वी हैव शिफ्टेड इट 4 सेंटीमीटर, दिस इज 12 सेंटीमीटर। नाउ यहाँ पे मैं लिखता हूँ इसे, दिस इज 12। नाउ वी हैव शिफ्टेड this particular mirror 4 सेंटीमीटर टुवर्ड्स द ऑब्जेक्ट, यानी इस तरफ ऐसे शिफ्ट किया, कितना 4 सेंटीमीटर। लेट से द न्यू पोजिशन ऑफ द मिरर इज लाइक दिस, यहाँ पे है, दिस इज द न्यू पोजिशन ऑफ मिरर एंड इट हैज शिफ्ट 4 सेंटीमीटर। नाउ व्हाट इज दिस डिस्टेंस, टेल मी, if the total distance from this position to object is 12 centimeter and this much is 4, so this will automatically become 8 centimeter. Clear? And what is the rule of image formation in plane mirror? If an object is lies as x distance away, the image will also lies x distance away. Very, very good. Yes, sir. Very good. So now the new position of the image, this is the previous position. New position of image will also shift if this distance is 8 centimeter. Object, now the new distance of the image will be also 8 centimeter. Here is the image I dash, and this distance from the new position of mirror is 8 centimeter. Clear? Now, if you will see here, this distance is 4 and this total distance from here to here is 8 and this distance is 4 centimeter. यहाँ पे ये 4 centimeter है, तो ये distance कितनी हुई, ये भी 4 centimeter हुई, है ना, 4 and 4 तभी तो 8 बनेगा ये, 4 and 4 is 8. क्लियर? अब कितना शिफ्ट हुआ इमेज फ्रॉम इट्स इनिशियल पोजीशन, यहां से ये 4 सेंटीमीटर है, ये नई पोजीशन है इमेज की ये, ठीक है, क्लियर है। तो इमेज मेरा कितना शिफ्ट हुआ है, दिस मच ऑफ डिस्टेंस, दिस मच। नो, पे अटेंशन टू दिस क्वेश्चन, देखो इमेज मेरा यहाँ पे है, इस पोजीशन पे, लेट मी चेंज द कलर हियर, इमेज ये नई पोजीशन ये है, ठीक है, एंड ये पहली पोजीशन से 4 सेंटीमीटर है और यहां से ये वाली जो टोटल डिस्टेंस है कितनी है, 8 सेंटीमीटर। तो ये कितना शिफ्ट हुआ, ये कितना शिफ्ट हुआ, अगर ये 4 सेंटीमीटर है, इफ दिस इज 4 सेंटीमीटर, दिस इज 4 सेंटीमीटर एंड द टोटल इज 12, तो ये कितना हुआ, 8 सेंटीमीटर शिफ्ट हुआ ना। अरे ए सर, व्हाट यू आर डूइंग, 12 सेंटीमीटर कैसे शिफ्ट हो जाएगा भाई, यू नॉट अंडरस्टैंडिंग दिस। लेट मी गो ऑन टू द न्यू स्क्रीन फॉर यू, चलो ब्लैक करते हैं इस स्क्रीन को। ये मेरे पास मिरर है, ठीक है, ये ऑब्जेक्ट है, ये इसकी इमेज बनी, इनिशियली दे आर एट अ डिस्टेंस ऑफ व्हाट, 12 सेंटीमीटर एंड 12 सेंटीमीटर, ठीक है। नाउ वी हैव शिफ्टेड दिस पर्टिकुलर मिरर बाई 4 सेंटीमीटर, ये डिस्टेंस कितने हुई, 4 सेंटीमीटर, ऑब्जेक्ट की डिस्टेंस तो चेंज नहीं, दिस डिस्टेंस इज 8 सेंटीमीटर नाउ, न्यू डिस्टेंस फ्रॉम द मिरर, तो न्यू पोजिशन ऑफ द इमेज विल बी 8 centimeter from this point. This is 4. This gap is what? 4 centimeter, which means more 4 you have to travel. 4 plus 4. यहाँ पे आई डैश आ गया, ये टोटल डिस्टेंस कितनी हुई, 8 सेंटीमीटर। अब यहां से यहां तक इमेज कितना शिफ्ट हुआ, दिस मच। ठीक है, ये डिस्टेंस कितनी है, 4 सेंटीमीटर है, और ये टोटल डिस्टेंस कितनी है, 12 सेंटीमीटर है। तो इमेज कितना शिफ्ट हुआ, इतना ही तो शिफ्ट हुआ ये। तो ये कितना बना, 4 - 12, सॉरी 12 - 4 इज 8 सेंटीमीटर। अब बताओ किसी को कोई डाउट है इसमें, एनी काइंड ऑफ डाउट इन दिस? ए सर, नाउ यू हैव अंडरस्टूड इट? देवा एंड ए सर, टॉप। मधुकर, स्नेहा, जेएनवी, करिकल, कराइकल, ए सर, देवा। ठीक है ना? ओके। ओके देवा। ठीक है, तो इसका स्क्रीनशॉट ले लेना आप, इस क्वेश्चन का। चलो, नाउ वी विल डू, तो करेक्ट ऑप्शन इज 8 सेंटीमीटर टुवर्ड्स द मिरर। ठीक है, ये वाला होगा, प्रीवियस वाला नहीं। अब बात करेंगे डेविएशन फ्रॉम द प्लेन मिरर। ठीक है, डेविएशन का मतलब क्या होता है, द रे, हाउ मच, जस्ट लेट मी चेंज द कलर, हाउ मच एंगल और रे has been shift from its original path, that angle is termed as, that angle is termed as what, deviation, angle of deviation. Okay, and this phenomena is called deviation. Yeah, deviation mean bending, kind of, you can say deviation is nothing but bending of ray from its original path. तो देखो ये हमारी इंसिडेंट रे, दिस इज द इंसिडेंट रे, this is incident ray, and this is the reflected ray. The angle made by the normal is I by the incident ray, and the angle made by the reflected ray is R. Got it? If you will see the original path, if there is, this mirror is not present, suppose if the mirror is not present, then light will come through this path, ये path follow करती light, which means इस original path से light कितना shift हुई, this much amount of angle, this angle has been shifted. ठीक है, दिस एंगल इज टर्म्ड एज डेविएशन विच इज गिवन बाय डेल्टा। सो लाइट का ओरिजिनल पैथ कौन सा था, ओरिजिनल पैथ है ये। ठीक है, ओरिजिनल पैथ, ओरिजिनल पैथ से कितना शिफ्ट हो गई, दिस अमाउंट ऑफ एंगल विच इज डेल्टा। तो इसे हम क्या बोलते हैं, डेविएशन बोलते हैं। द शिफ्टिंग ऑफ अ पर्टिकुलर रे फ्रॉम इट्स एक्चुअल path is termed as deviation, and the angle between the reflected ray and the original path is termed as angle of deviation. Clear? किसी को कोई डाउट है इसमें? Now, how to calculate this angle of deviation? That is the question here. We know that according to according to law of reflection, angle I is equals to angle R. ठीक है? Clear? Now, this total angle, ये total angle कितना है? This angle is nothing but pi. कह सकते हो? So can we say that this pi angle is equals to I plus R plus delta? किसी को कोई डाउट है इसमें? I plus R plus delta is also resulting in pi. Now I and R are same from equation 1. So delta here is nothing but pi minus 2 pi or pi minus 2R or pi minus 2R. No. Deviation occurs because of the mirrors. ठीक है? In the absence of mirror, अगर यहाँ पे मिरर होता ही नहीं तो light will not reflect and light will not deviate from its original path. So it happens because of some object come in the path of light. ठीक है? तो लाइट के रास्ते में जब हम कोई ऑब्जेक्ट रख देते हैं तभी डेविएशन पॉसिबल है, otherwise there is no deviation in the path of light. Clear? So based on this, let's just try to solve this question. इसे क्वेश्चन को सोल्व करो आप. जेई मेन 2023 है. ठीक है? When one light ray is reflected from a plane mirror with 30-degree angle of reflection, angle of reflection is given you as 30 degree. The angle of deviation of the ray after reflection is, और देखो लेटेस्ट है ये, जेई मेन 2023 में ही आया अभी. Let me know the answer in the chat box. I'm not going to solve it for you because it's very easy peasy type of question, and it is also a 4 mark question. So can you imagine, this 4 mark is for free. ठीक है? Everyone has to solve this question. Meanwhile, I am launching a poll. Please do participate in that poll and answer each and every question so that I can mark your attendance also. ठीक है? So when one light ray is reflected from a plane mirror with 30-degree angle of reflection, the angle of deviation of the ray after reflection is very simple, which is delta is equals to pi minus 2y. Now pi minus, r is given in terms of degrees, so we have to convert it into radian. So r will become pi by 6. You have to remember that 30 degrees directly pi by 6, 60 degrees pi by 3, 90 degrees pi by 2. ठीक है? 273 degree will become what? So pi minus 2 into I की वैल्यू क्या है? I is equals to R. If it is reflecting, which means angle of reflection or angle of incidence is same. So I will become here pi by 6, 3. So pi minus pi by 3 will become 2 pi by 3. But angle is given in terms of degree here. तो यहाँ पे आप ऐसे भी लिख सकते हो, डेल्टा इज इक्वल टू 180 minus 2y directly. 180 minus 2 into 30, which is 60, which is 120 degree. अब यहाँ से आपको ये भी पता चलेगा कि 120 डिग्री को हम 2 पाई बाई 3 लिखते हैं in terms of radian. Got it? Very good, Nagashri. Everyone who has responded, very good. So I hope you have responded in the polls also. Please do participate. 9 students are remaining in participating the poll. Please do participate in the poll. किसी को कोई डाउट हो तो पूछ लो आप. ठीक है. वेरी गुड सर. चलो एक छोटा सा कॉन्सेप्ट और बता देता हूँ आपको. डेविएशन प्रोड्यूस बाय टू मिरर्स. अगर दो मिरर हैं, एक एंगल पे टिल्ट है, व्हाट इज द डेविएशन प्रोड्यूस बाय दैट. अब देखो ये इंसिडेंट रे आई, इसे जाना चाहिए था ऐसे ओरिजिनल पैथ पे, बट ड्यू टू द प्रेजेंस ऑफ दिस मिरर इट रिफ्लेक्ट बैक. अगेन इट स्ट्राइक ऑन दिस मिरर. अब इस अगर ये मिरर नहीं होता, इन द एब्सेंस ऑफ दिस मिरर टू, दिस लाइट विल गो इन दिस वे, but due to the presence of this mirror it will reflect back on this path, which means here we have two types of deflection. First is delta 1. देखो, this is the retraced path and this is the original path. तो original path और actual path के बीच में जो एंगल है, that is angle of deviation. Again ये लाइट को ऐसे जाना था, but it moves like this, so this is delta 2. ठीक है. So we can say first रिलेशन हियर इज थीटा इज इक्वल्स टू अल्फा प्लस बीटा. एक तो ये आपको याद रखना. थीटा इज द एंगल बिटवीन टू मिरर्स एंड अल्फा एंड बीटा इज द एंगल ऑफ इंसिडेंस फॉर टू रेज. देखो जब यहाँ पे रिफ्लेक्शन हुआ, यहाँ जो एंगल है वो बीटा है. फर्स्ट टाइम द एंगल इज अल्फा. व्हाट इज. सो डेविएशन हियर इज नथिंग बट डेल्टा 1 प्लस डेल्टा 2. अगेन डेल्टा 1 को हम लिखेंगे पाई माइनस अल्फा. Delta 2 will be written as, sorry, pi minus 2 alpha, pi minus 2 beta. This will become 2 pi. ये मैं कैसे लिख पा रहा हूँ, इस फिनोमिना की मदद से. डेल्टा इज नथिंग बट पाई माइनस 2 आई. So pi minus 2 alpha for first reflection, pi minus 2 beta for second reflection. It will become 2 pi into 2 minus alpha plus beta. Now this alpha plus beta is theta from this relation. So here delta is 2 pi minus 2 times of theta. Delta is 2 times of pi minus. This is the deviation produced by two mirrors. Clear? चलो एक और क्वेश्चन कर लेते हैं ये. This phenomena. So अगर if mirror is stationary, then reflection will happen. Now mirror has been rotated with an angle theta. Now what is the change that would come? Change is come in that case. The reflected ray will be shifted by the double angle. If you rotate the angle, if you rotate the mirror by angle theta, then the reflected ray will rotate by an angle 2 theta. The condition is that you need to keeping the direction of the incident ray constant. We are not disturbing the incident ray. We are just disturbing the mirror. So this ray, which is reflected ray, is rotated by an angle 2 theta. So here we can also say, if the angular velocity of mirror is d theta by dt, then the angular velocity of reflected ray will be 2 times of d theta by dt. Which means we can say, if you rotate the mirror with angular speed of omega, then the reflected ray will be rotated by an double speed of that. ठीक है. Omega r is 2 times of omega m. This is omega r. Got it? So this is a very important relation. You must remember this. Now, if anyone has any kind of doubt, you can ask. Otherwise, the lecture is being over. Thank you so much for being attentive and being responsive in the lecture. Bye-bye. Take care of yourself.